Hey Sharks, it's Miss Luter going over writing scientific notation. So scientific notation is when we have a very large number or a very small number and we have to write it in an expression that has a single digit whole number multiplied by 10 to an exponent. In order for us to do that, we will start with a large number like 25,000. And our first step is to move the decimal so it becomes a single digit whole number. So if 25,000, the decimal is behind the last zero, and I need to move it so that it is in between the 2 and the 5. This becomes a whole number, 2.5. So let's count to see how many decimal places we had to move. 1, 2, 3, 4. 25,000 now becomes 2.5, and we can write that single digit number 2.5 times 10 to a certain power. Now 25,000 has a whole bunch of zeros, and those zeros are just placeholders. So when we move the decimal to become a single digit number, you can drop those zeros off. So it just becomes 2.5 times 10 to a certain power. And remember I said to count how many times you had to move the decimal? Because we had to move the decimal 4 places to the left, we now know that 4 will be the exponent for 10. And so our full scientific notation expression will be 2.5 times 10 to the power of 4. So let's try these. We have 5,400,000, and if I move my decimal to become a whole number, a single digit whole number, it would have to be moved between the 5 and the 4. So we have 5.4 times 10, and we need 10 to a certain power. So let's count how many times did we have to move the decimal. 1, 2, 3, 4, 5, 6 times 10 to the power of 6. Ta-da! Now I have written it in the scientific notation form. So now we have 23,189. So I need to move that number to become a single digit whole number, meaning the decimal has to move between the 2 and the 3. Now notice we have these 0 placeholders, and they're important because I still have these numbers 1, 8, and 9 in this number. So now I have that single digit whole number 2, point all of those extra numbers, times 10 to a certain power. Now, in order to identify what our exponent is, we have to count how many times we moved the decimal from the original decimal place to the new decimal place. So starting behind the 0, we have 1, 2, 3, 4 decimal place movement. So our exponent is 4. Now notice I said up here, we can just drop these zeros off because they are placeholders behind important numbers. But here, these zeros are in between important numbers, so I cannot just drop them off. So now I have 2.3000189 times 10 to the power of 4. C, 468. Well, that one's easy. 468 is going to become 400.68 times 10 to, going from the hundreds place to a singles place means I have to move the decimal 2 times. Moving the decimal 2 times to the left means I have a positive 2 for my exponent. Whoa, here we have 600,000.2. Although these zeros are placeholders, because I have that 2 behind it, I need to keep those zeros. I have a single digit whole number. Decimal is going to be moved in between the 6 and the 0. And I have 5 zeros and a 2 at the very end. Times 10 to a certain power. My exponent is the number that I counted the decimals. So we've got 1, 2, 3, 4, 5 times I moved the decimal. So my exponent is 5. 6.000002 times 10 to the 5th power will be my scientific notation. Well, that was easy. So what if we had to work it the opposite way? What if we had to write scientific notation into standard form? Well, all standard form is just regular numbers. And there's two different ways that you can take scientific notation and rewrite the expression in standard form. So the first method would be to be paying attention to these exponents and understanding that the exponent is how many times you move the decimal. So if I had to change 5 times 10 to the power of 3, remember the whole number is 5, and that the decimal is behind the 5. The exponent is going to tell me how many places to move the decimal, and a positive exponent means that I'm going to have a larger number, so I need to move the decimal to the right. The exponent 3 tells me to move the decimal 3 places to the right. So I have 5 point, but I have to do 1, 2, 3 decimal place movements, and 5 becomes 5,000. Now because I just had 5, I'm going to have to fill in those empty spaces with zeros. And that's how 5 becomes 5,000. So going from a scientific notation to standard form, we went from 5 times 10 to the power of 3 to the standard form number 5,000. And I would just continue doing that. Even if I had decimals behind, or digits behind my decimal, like example 2, 7.25 times 10 to the power of 6. The exponent tells me I need to move the decimal 6 times to the right. And even though I have digits behind my decimal, that 2 and the 5 are going to be my first 2 movements. So I have 2 and 5 is 1, 2 moves, and then I have to move 4 more. 1, 2, 3, 4. Alright, so let's see. If we were behind the 7, we have to make 6 full digit movements. 1, 2, 3, 4, 5, 6. So that 7.25 becomes 7,250,000. And those extra decimal places I just filled with a 0. I hope that makes sense. Then we have these type of numbers where I have lots of digits behind the decimal and a small exponent. It still just says to move the decimal 2 places. So starting with the decimal, the original spot, moving it 2 places, so it's now behind the 4. We went from 6.9403 to 694.03. Remember, positive exponents tell me that the number is going to become larger. And the exponent is how many times I have to move the decimal. So that's the first method. So if I had 4, I'm going to have to move the decimal 4 times to the right, which means I need placeholders. Moving it 1, 2, 3, 4 times. 1, 2, 3, 4 times. That means 4 becomes 40,000. If I had 2.86 times 10 to the 4th power, I have 2, and I have to move the decimal. So I've got 8, 6, that was my first 2 moves, and I need 2 more. So 2.86 becomes 28,600. And then if I had this long decimal, 8.8035, and I need to just move the decimal place 3 spots to the right, my 8.8 becomes 880.3.5. So my original decimal was between the 8 and the 8, and I had to move it 1, 2, 3 times to the right. So 8.803 becomes 8,803.5. So that's the first method of just simply using the exponent to tell me how many times I need to move the decimal. There's also one more method. There are some really important exponents for you to kind of get an understanding with. You can almost memorize these. So we can use a power of 10 chart. Anything to the power of 1 is a tens. Anything to the power of 2 becomes hundreds. Anything to the power of 3 becomes thousands. Power of 4, 10,000. Power of 5, 100,000. Power of 6, 1 million. Just like that. So these exponents are talking about how many zeros or how many placeholders are in a number. And we can kind of just get an understanding of what type of number the standard form will be by going off of the exponent. 3 times 10 to the power of 3, that third power means the thousands. So we would take 3 and it becomes 3,000. That was easy. 6.72 times 10 to the power of 2. Second power means I'm talking about hundreds, right? So that 6.7 has to turn into 600.7. I'm sorry, 670. 6.7 becomes 670, moving the decimal place and knowing that the exponent of 2 is talking about a hundred. So we've got 6.7 becomes 670. Well, let's check out example 6. 9.562 times 10 to the power of 6. Well, anything to the power of 6 means millions. So automatically, I know 9.562 is going to become 9 million and something. So I've got 9,562,000, and I can just fill in the rest with zeros. And then last but not least, we've got 4.0167 times 10 to the second power. Second power means hundreds, so automatically I know I'm going to have 401, and then the digits behind the decimal just stay there. 401.67. So let's try this one. 7 to 10 to the power of 4. 4 is thousands, so automatically 7 becomes 7,000. Correction, 4 is 10,000. Let me double check. 4 is 10,000. Knew that looked funny. Okay. 4 is 10,000, so it goes to the 10,000s place. Let's use that chart. There we go. All right, we've got 10 to the power of 3. So 3.62 times 10 to the power of 3. Well, anything to the power of 3 is the thousand spot, so automatically I know this is going to be 3,000 and whatever is behind the decimal, filling in with that extra 0 as the place value. 1.30004 times 10 to the power of 2. Anything 10 to the power of 2 is 100, so I know this is going to be 130, and that anything behind the decimal stays the same. 130.004. So that is how we go from scientific notation, how to go from scientific notation to standard form. Both going from standard form to scientific notation, understanding how we move the exponents to the left to become the, understanding that we move the decimals to the left to become the exponent, and then when going from scientific notation to standard form, understanding that the exponent becomes how many digits are in the regular number. All right.